So hello friends, welcome back. Today we are going to see how to simulate a heat exchanger in a open source software. Here we are using DWSIM. So what are we going to learn today? First is definitely to how to make a digital twin or simulate a heat exchanger. Then how to find out outlet stream temperatures, LMTD and thermal efficiency. We are going to use as our streams as water and methanol. So the properties of water and methanol are given. So water will be our cold stream, which will be at 10 degrees Celsius and 1 bar pressure, flowing at 15,000 kg per hour. Methanol is our hot stream, which you want to cool, which is at 80 degrees Celsius and 5 bar pressure and flowing at 25,000 kg per hour. So mole fraction, here I have considered XW is equal to 1, that is the mole fraction of water in the water stream is 1, and definitely methanol is 0 and vice versa in methanol. What are the heat exchanger properties which we are looking at? So overall heat transfer coefficient we will be taking at 450 watt per meter square Kelvin. Heat exchanger area is 250 meter square. Cold fluid pressure drop is 0.002 bar. Hot fluid pressure drop will be 0.025 bar, and package will be using Raoult's law. So let me go to the interface of DWSIM and let us start our simulation. So here I am on the interface of DWSIM. You can see the tab New Steady State Simulation. Just click on that, or you can also do it by using File, New Steady State Simulation. This window will open. On left hand side you can see Introduction, Compounds, Property Packages and System of Units. This is nothing but to configure our stream properties and compounds. I'm I will press next, select water, then type methanol. So here I am selecting the compounds which are water and methanol. Water is our cold stream and methanol is our hot stream. Press next. Then property package which we are going to use is Raoult's law. Double click on that. If you don't double click on that, it will not get selected and it will show you an error. Next, then system of units is C5. Click on finish. I am closing this window so that my white sheet will be elaborated. Okay. So on downside, you can see a material stream here. So just drag and drop two material streams. Okay. Now double click on this first material stream. I am giving it as water in and press enter. Then on downside, you will see input data under which flash spec is given by default as temperature and pressure. So temperature, as we said, of our cold stream is 10 degrees Celsius and pressure is 1 bar and it is flowing at a rate of 15,000 kg per hour. After configuring this, go to compound amounts. So in cold stream, which is water, the mole fraction, which is a basis. So you can see here mole fraction bases are given. If not, please select that. So water is 1 and obviously methanol is 0. Press enter and accept changes. Click on accept changes. My water inlet stream is configured now. Similarly, we have to do it with methanol inlet stream. I will double click on methanol inlet stream. Object, I will name it as methanol in, press enter. Then flashback, temperature and pressure. So temperature we said it is at 80 degrees Celsius and pressure at 5 bar, and mass flow was 25,000 kg per hour. Again go to the compound amounts, select basis as mole fraction, click on water, type it 0, click on methanol, type it 1, press enter and click on accept changes. Now next I want to configure is our heat exchanger. Heat exchanger symbol is given here. So I will just drag and drop it here. Also I need stream outlets. So I need two streams, that is water out and methanol out. Downstream, which is I will type it as water out. I am not changing any other properties because this is our outlet stream. So answer for this which we are expected to find, and this one as methanol out. Now double click on heat exchanger. Here we have to configure our heat exchanger now. The inlet stream 1 is methanol in, inlet stream 2 is methanol out, inlet stream 2 is water in, and outlet stream 2 is water out. You can see all these streams are now connected. So I am just maximizing it for better view. Now calculation type is outlet temperatures we want to find, and flow direction is counter current. This is a counter current heat exchanger. As we said, the cold side fluid pressure drop was 0.002 bar, and hot side pressure drop was 0.025. Global heat transfer coefficient 450, as we said earlier in our slide, and his heat exchanger area is 250 meter square. So now my heat exchanger is configured. You can see everything has turned blue. It's time to run our simulation now. So go to the top of this interface and you can see a solve flow sheet option. Just click on that, and this is solved now. Let me go to my results. So here are the results. So thermal efficiency you get is 94.508. Log mean temperature difference is 10.29. Now let me also show you how to get the elaborated results. Go to insert and click on master property table. You will see a small black box appearing on your screen. Just double click on that. Name, just give it stream properties. Object type, keep it mainstream, and below object click all, everything select. Then on right side go to the property which you want to see on the screen. There is temperature, pressure, mass flow, molar flow, and also molar fraction mixture water, and I will also consider molar fraction mixture of methanol, and close this box. You will see this property table appearing here. So just drag and drop it down so that I can make a space for another table which is heat exchanger properties. So go to insert again, click on master property table. Again a black box will appear on your screen. Double click on that, and here just give it a name, heat HE properties. Object type change it to heat exchanger. click on object as heat exchanger, then select global heat transfer coefficient, heat exchange area, heat load, cold fluid outlet temperature and hot fluid outlet temperature. You can also choose logarithmic mean temperature and thermal efficiency, and just close this box. So you can see this box is appearing here, and just drag and drop to make it a suitable view for analysis. Okay, now you can see this is a snapshot of our heat exchanger simulation, and that's how you can easily simulate a heat exchanger with a counter current flow in DWSIM software. And there are a lot of things which you can change and check of what are the differences or what are the impacts on the parameters. And thank you friends. If you like the content, please like it, share it and subscribe to my channel. Your subscription and likes will encourage me to bring in new content and make new videos which will help people to get jobs. Thank you.